Welcome back to Natalia's classroom. I hope you are learning time series analysis in Python with me. Please like, share, and subscribe if you want to learn in an easy way. What we have learned so far is that in the first three steps of time series analysis, by the way, I'm giving the links in the description box in case you have missed any of the steps. We have actually made our data stationary and we have seen the results as well. Today we are going to check out the ARIMA model in detail, and as we have made the data stationary now, let us compare the results and see the p values. So here the data is stationary, and I have run the add fuller test, and it is showing me the results according to the stationary data. So as we see, the p-value is quite good, and it indicates that the data is stationary. So if you want to know more about the add fuller and how to do the check, how to perform this statistical formula on the data to check its stationarity, you must visit my previous videos and you will learn in detail that how can we do it. So let us move on to the details of ARIMA model. Okay, so ARIMA model is actually um, a combination of three values. AR means auto-regression, I means integrated, and MV means moving average. So AR basically means that we are using the previous values of the time series in order to predict the future. Actually, how many past values we use will determine the order of AR model. So this is going to be the first parameter for ARIMA model. Then the moving average, and this is basically means that we are using previous errors to make future prediction, and it is always good if we consider the previous errors so that the prediction can be a better prediction. And it is just like in autoregressive model, the number of previous errors, also called the number of lags that we use, determine the order of the model. So this is the third parameter of ARIMA model. I stands for differencing, or integrated stands for differencing. If our data set is not stationary, then we usually use some sort of difference operation to make it stationary, and that is the parameter for I. So if you're differencing with the previous value, this order is 1, and if you can change this order as well. So we simply supply our data to auto ARIMA, sorry, to the ARIMA function, and we have to pass these three parameters like P, Q, and R, as you can see here. So P, Q, and D, sorry. And the P stands for autoregressive, D means integrated, and Q means moving average. What is the best order? That is actually the issue right now, and we need to find out a very good and fitted order for ARIMA prediction. So for this, we need to calculate the minimum AIC score, and to calculate the AIC score, we will use the PMD ARIMA libraries fitting method, and it will automatically give us a nice order of nice values for PQ and PD and Q, and we will just use it in our function. And this AIC value is actually a method to quantify the good order for parameters. So let's move on and see the coding details of all this we have talked about. Okay, let us find out the perfect order for ARIMA analysis, and for this, let's import from PMD ARIMA, import auto underscore ARIMA, and we will be ignoring the warnings because there are certain uh, orders that will generate some warning, so we will ignore them by import warnings and then filter warnings. Okay, warnings dot filter warnings ignore. So it was giving me error for PMD ARIMA as PMD ARIMA package was not installed. Actually, I installed it earlier, but there was some problem, I think. So I have written this command pip install PMD ARIMA, and it has installed PMD ARIMA for me. Okay, so now as we have told it to ignore and filter the warnings, let's move on to find out the AIC minimum AIC score and find out the successful ARIMA order. So for this, let's do the wise underscore fit is equal to auto underscore ARIMA, and then we have to pass it our dataset. The name of our final dataset after stationary is smartphone underscore st. So this is smartphone underscore st, and we have to take the value as well. So wise underscore fit is equal to auto ARIMA smartphone st average, comma, trace is equal to true, and express warnings is equal to true as well. I have just executed it. Wise underscore fit is equal to auto ARIMA. I have given the name of my dataset of that is the stationary dataset. Then trace is equal to true and express warning is equals to true. And after this, it is creating the combinations. These are some some warnings, and we are going to ignore them. So these are the orders, stepwise search to minimize the AIC, and here it is 2, 0, 2, and that is the AIC. So we have to find the minimum AIC for ARIMA model. So it will keep on executing, and after some time it will stop, and best model, it has given us this is the result, this is the best model. So the order we are going to put is 1, 0, 3, means p value is 1, d value is 0, and q value is 3. So this is how we can find the perfect order for ARIMA model, and from here we will continue to do the analysis. And for doing the analysis with ARIMA, first we need to split our data set into test data and train data. So the step number 5 is going to divide the data into test and train, and then we will implement this order. So what we have done so far, I will give the links in the description box for the previous steps of time series analysis from step number 1. to step number 3, and 4 or 5 are being recorded in this and being covered in this video. Supplied our dataset to the AutoRIMA function, and the function basically calculated the AIC score to judge how good a particular order model is, and it this function simply um, tries to minimize the AIC score, and it quantifies a good order of parameter for P, D, and Q. And here we can see that this function gives us the best model as an output, and it is 1 comma 0 comma 3, means P is 1, Q is 0, and D is 0 and Q is 3. And this particular model order has the minimum AIC score. Let us see it. Um, this is 10103, and the AIC score is 269. That is the minimum of the all the test it has done. 272, 268 is also less, and it is again 103. So this is the minimum score. Otherwise the scores are above 270 or 272 or 273. So what I actually did, I simply used the PMD ARIMA auto ARIMA function, and I gave it my uh, dataset, stationary dataset, as a parameter, as an input, and it has found a wise fit for my data. And these are the execution details of this function. So this is the order that I am going to use in ARIMA analysis, and when I will call the ARIMA method, I will use this order 1 comma 0 comma 3, and let's see how we will do this. So we have got the minimum AIC score, and the next step is to split the data set into test data and train data. Uh, why we are going to split the data set is because we are going to train our model. This 1 0 comma 0 comma 3 ARIMA model, we are going to train it on the training data, and once our model is well trained, then we will use it to do predictions on test data. And if it does the same predictions for us as in the test data we already have, then it means that our model is good. So for this, we are going to first of all check the length of the data, and for checking the length of the data, we will use the dot shape operator and check the length of the data. So let us write commands for this. So the objective here is to split the data set into test and train data sets. So the first step is that let us check the size of our data set. Print smartphone underscore st dot shape. So this function usually gives us the size of our data set. So we have 54 records in it, in the average age, and let us split it into our train and test. Let's make our train data set first, and train is equal to smartphone underscore st dot ilog. So ilog is the index location parameter, and if you want to know the details of this, you need to go to the playlist of Python programming, basic Python programming for data science, and you will find out how to use this parameter. So ilog is actually a function that will use the index based location, and this is how I will split it. I will give it colon 34. So there are 54 records, and from 0 to 33 means 34 records I am going to put in my training data set, and the rest will be in my test data set. So smartphone underscore st dot ilog, and here rest of the onwards 34. So 34 column means starting from 34 till the end of the data set that I have. So again, I will put the link of basic data science, basic Python programming for data science course or tutorial into in the description box. So my test data and train data has been created. So out of 54, 34 records are in the train data, and remaining 19 records are in the test data. So let us check it again. Print train dot shape, comma, test dot shape. So this function will give me the size of my train and test data. So see, 34 records are in my training data and 20 records are in my test data. So I will train my ARIMA model on 34 records, and then I will test and I will do predictions for these 20 records. So this is the step where we have created our or splitted our test data and our time series data into test data and train data. So we have reserved, and simply we need to call the ARIMA function and supply our train data set to it. So let's do this. So for this we need to import ARIMA function from stats model. So from stats model dot tsa dot arima underscore model import arima, and then model is equal to arima, and now here I will give my training data set. First of all, train, and from train data set I am using the average age column. The second thing I am going to pass to this ARIMA method is the order of my minimum AIC score, that is 1, 0, 3. So P, D and Q respectively. Okay. So after this we are going to do model is equal to model dot fit, so that it can do the necessary take the necessary actions, and then model dot summary, so we can also see some information about our model. So this is where I am going to use the training data to build a model that is going to be a fit model for my time series data analysis, for doing predictions on my test data. So let's run it. Okay, so there was a typing mistake. It is stat models. Order is equal to. So this is the these were the sorry for the typing mistakes. So these were little typing mistakes we often get. So from stats model I imported the ARIMA method, and from ARIMA method I am passing my train data to it with the order of the minimum AIC score, and then I am trying to create a fitted model, a perfect model for my based on my train data to predict the future values. So this is some summary that this is a little bit summary that it is showing. So here the coefficients are actually the some constant that are in our auto regression and moving average methods. So this is very simple, and after this we are done. We have trained our model, and we have created a model for time series analysis. The step number 6 will be to use this model that we have created, to use this model to predict the values in our test data.